The mean time it takes to service 45 customers at a drive-through fast food restaurant is 165 seconds. Use StatCrunch to find a 98% confidence interval for the mean of the sample standard if the sample standard deviation is known to be 15 seconds. To figure out our best point estimate, the best starting point to figure out the population mean is going to be using the sample mean. The sample mean in this problem is X bar is actually 165 seconds. So that's our best point estimate. To figure out the margin of error, we're going to wait a minute and actually construct the confidence interval and work backwards. So to construct the confidence interval for the mean time it takes to service customers at a drive-through restaurant, we're going to have to take our sample mean minus our margin of error and take our sample mean and add our margin of error. So now on StatCrunch, we're going to use these directions. We're going to go to Stat. Then we're going to go to what's called T-stats. And we're going to use T-stats because we have the information that we're going to use, find a confidence interval for a mean, but also we know the sample standard deviation. We're going to go to T-stats, stat, and then we're going to go to T-stats, one sample, and then with summary. So our sample mean, we're going to use X bar as 165. Our sample standard deviation, S, we know is 15 seconds. And our sample size, N, is going to be our 45. So let's go ahead and enter that in and make sure we're going to find then the confidence interval for a mean. Entering those values in, again, we're going to take the sample mean as 165. Our sample standard deviation is 15. Our sample size we said was 45. And we're going to do the confidence interval for the mean. And we're going to change our confidence interval level to 98%. And we're going to go ahead and hit compute. So in this, it gives us our sample mean. Unfortunately, remember, it does not give us our margin of error. I wish StatCrunch would give us that. We give us our degrees of freedom, and then it gives our lower limit and upper limit to be able to use. So our answer is going to be 159.60183 is our lower limit, and 170.39817 as our upper limit. So again, what we're going to now do is use this to figure out our margin of error. To figure out our margin of error, we're going to take the 170.39817, subtract off the 159.60183, and we're going to divide the answer by 2. Bringing up our calculator. Let's go ahead and type that in. Open parentheses, 170.39817 minus 159.60183, close parentheses, divided by 2. We hit enter, and it should give us our margin of error as 5.39817. So if we were to complete our formula here, we would notice here that the x bar, remember, is 165 seconds, and we would subtract that margin of error, 5.39817. And just to prove it to you on our calculator that that indeed is true, we can take that 165 minus 5.39817. There we go, and there you go. It's the same answer. And then we take the other number, the mean, which is 165, plus our margin of error, 5.39817. So we take 165 plus 5.39817. We hit enter, and we get our upper boundary. So how does our sentence go? Our sentence will go like this. We are 98% confident the population mean time to service customers at a drive-thru is between 159.6018 seconds and 170.392 seconds. So remember, we don't know the actual population mean time, but based on this information, we can predict the mean would be with 98% confidence between those two intervals.